start again. Okay, let's go. So if you expand this out, you get 8x cubed 60x squared plus,
That's before you differentiate.
yeah, plus 125. So there's our expansion. And then we can do dy of dx. And what does that give us?
Is your final answer 2 minus 2?
What does that give us?
Okay. And then x squared minus 2x minus
24x squared plus 120x plus 50. And the question that obviously I'll ask is, the question, could you just quieten them please, or just whisper if you need to talk? Right, so the question that I'll obviously ask is, what happens if I make that power 30 and I say differentiate it? Will you do the binomial expansion for 30 terms, or is there an easier way to do it? Well, there is an easier way, and it's called the chain rule. And by the chain rule, what we're basically doing is differentiating. I'll just write this down. So with the chain rule, we're differentiating a function of a function. So it allows us to differentiate a function of a function. What do I mean by that? This is what I mean. What we could do is say, let the thing in the bracket, and normally it is what is in the bracket that you substitute. So let the thing in the bracket, let 2x plus 5 equal u. Now I've got an equation where y equals u cubed and u equals 2x plus 5. Okay? If I got y equals u cubed, okay, and I want to find dy of dx, we can have this relationship with the chain rule. Let's just do it term by term. If I got y equals u cubed, what would dy over du be? If I differentiate y with respect to u, 3u squared. Okay. We've also got u equals 2x plus 5. So if I write down du over dx, so I differentiate u with respect to x, what would you get? Du over dx. So you're differentiating u with respect to x. Maybe I should write this way. Anyone? 2. Okay. The question is, how do both of them now give us dy of dx? Well, you can think about fractions, although they're not technically fractions. Dy over dx equals, now this is the chain rule, dy over du times du over dx. That's the chain rule. Let me put that in a box. And let's highlight, let's just look at the pattern. You see the u's, pretend it was a fraction, the u at the bottom and the u at the top, if they cancel out, what you're left with on the right hand side? Dy over dx. That's what we're left with. Okay? So when you get trick questions, or when you get harder level questions, remember it always works out. If you were to cancel them off, you'll always get what you're essentially looking for. And so based on that, I can say dy over dx therefore equals dy over du, which is 3u squared times 2. This gives us 6u squared. And now we can substitute it back in, because the question started off in x's. We know what u is. U is 2x plus 5. And then it's all squared. There's our answer. If needed, we can then expand this out and come up with the same expansion that we've had over here. Is that okay before we continue? Any questions? No? Happy? Oops. Okay, there you go. Alright, in that case, let's look at an example. Let's do example 1. And say y equals 3x squared take away 4, okay, to the power of 7. Do you want to do that, or should we do it together? Hands up if you feel like having an attempt. Hands up if you want me to do it. Alright. So you've got y equals, now obviously straight away I can see, look, it's going to take the binomial expansion, and it's going to take quite long. So what I'm going to do is I'm going to tell the examiner, let u equal 3x squared take away 4. Therefore, y now equals u to the power of 7. And so I'll write down what I'm doing. Dy over dx equals dy over du times du over dx. Now, du over dx equals 6x, and dy over du equals 7u to the power 6. So power comes down, take 1 away from the power. And so therefore dy over du is 6x times our 7u to the power 6. 6 times 7 gives us 42, times the x times u to the power 6. We go back to our original substitution, so that gives us 3x squared take away 4. Put it in a bracket, the whole thing to a power 6, and that's it.
Well, I don't get the equal what? 6x?
Which one? 6x here?
No.
Here? Alright, so all I've done, let me highlight this. The dy over du, okay, dy over du is this part here, and that is 7u to the power 6.
What, so is it just set, what? Is it like what? There's a dot between.
That's just multiplying.
Oh.
Yeah, I didn't use a cross sign because it looks similar to the x which we're already using. And then if I use a different highlight, maybe green, and underline it, this du over dx is a 6x, and therefore you get the 6x off there. Is that okay?
Yeah.
Okay, thank you for that question, Craig. Any other questions?
What does the answer say? 42.
42 times x times 3x squared take away 4 to the power 6.
And you leave in that form.
That's it, yeah. Unless they say expand it out, but that's the simplified form. But I don't think someone's going to ask you to expand it out, unless it's some sort of binomial expansion question. Capiche? Alright, while you're copying that down, I'll just write down example 2. Should be example. Example 2. Let's have a go at differentiating y equals 1 plus x squared square root. Okay, why don't you have a go at that? And then we'll go over it. I'll give you about a minute. Don't forget, start off by saying let u equals something. Okay, have you got an answer? Okay, what do we have?
X times 1 plus x squared to the power of 1 minus 1 over 2.
Okay, let's go it together. 1 plus x squared. So what's our u going to be?
One
U will
plus
be
x
what?
squared.
Thomas.
Square root of 1 plus x squared.
Okay. How? Let's think about that. I've got 1 plus x squared. If I make the whole thing u, I haven't really done a substitution. I've said y is the same as u. But I want to simplify this whole expression. How can I put that in a bracket?
Be 1 plus x to the power half.
So 1 plus x squared
Yeah.
to the power of
Minus a half. Wait, a half.
a half. Yeah, so that's the square root. Agree?
Yeah.
Okay, everyone happy with that? Right, in that case, what would our u now be? What would you substitute? 1 plus x squared. Okay. So now it's an easier equation. Now we've just got y equals u to the half, where u equals 1 plus x squared. And so dy over du equals a half u minus a half, and du over dx now just gives us the 2x. And again, you should always tell the examiner what you're doing. So dy over dx is dy over du times du over dx. Okay, so dy over du, that gives us a half u minus a half, and then we're multiplying that by the 2x. Okay, we can obviously see the 2's are going to cancel, so that would cancel with the half, and we'll end up with x times u to the minus a half. We can now substitute our u, the original, back in, so x times 1 plus x squared to the power of minus a half. Is that okay? Hands up if you got that? Well done, excellent.
That's the one question 4B.
Alright, let's have a go at just hands up if you feel confident. You feel, yeah, I know I see how this works, I can apply it now. I can actually do questions, I feel fine. Alright, what I'll do is I'll do one question. Let's do a rates of change question, and let me try and insert the first part of it here. The second part hasn't come up too clearly for some reason, but I'll put it in. Put it in like this. Put it in like this. Probably not too clear. Okay. So we're now just going to use this for rates of change, and we're doing quite a bit of work on this. So the bank of a reservoir is modelled by this curve: y equals x squared, take away 50 minus 2, where x lies between 10 and 20, and x is measured in meters. Okay, so you've got this funny diagram which hasn't come up too well. Now the width of the reservoir is 15 meters and is increasing at a rate of 0.2 meters per day. Okay, and the width is x. So by the I don't think it's a question that's worded too well, to be honest, but I'll just emphasize that this width is our x, and this y is our depth. That's essentially what the question is trying to say. Calculate the rate of change of the depth of the reservoir. Okay. So what they're asking for, the rate of change always means something with respect to time. The rate of change always means that we're differentiating with respect to time, always. Okay, hence it's a rate. But we want the depth, so what we need here is a y. Agree? Alright. Can everyone just look up? Now this is where rates of change comes in. Now our idea about the fraction comes in dy over dt, okay, means that I'll have a dy over here and a dt over here. Okay, you can imagine them to be like fractions, although technically they're not. You're doing a derivative. And so what would go here? What's our other variable in terms of y? We've got time. What's our second variable? X, right? So therefore, this has to be x. So that's the chain rule we're going to be using. So we therefore, to find dy over dt, we just need to work out dy over dx, and we need to work out dx over dt. Agreed? Happy? Right. Can we work out dy over dx? How can we work out dy over dx? Do we have a relationship between dy over dx?
Yeah.
Is there something that connects the two, x and y? Yeah, it's given over here, isn't it? Yeah, this connects x and y over here. And so therefore, we can differentiate that, bring the power down, take 1 away from the power. Okay. And what happens to the 2? It just becomes, anyone, when you differentiate the 2?
It's gone.
It's gone. Okay. So there's our dy over dx, that's done. Can we work out the dx over dt? Well, there's no explicit equation other than saying when the width of the reservoir is 15 meters and is increasing at a rate of 0.2 meters per day. So that means when x equals 15, then we know that our dy over dx, which is what we just worked out here, so this is x over 25, then dy over dx will have to be 15 over 25, which gives us 3/5. But the rate of increase is 0.2 meters per day. So we've been told dx over dt is 0.2. I'll just highlight that in yellow. They've said it's increasing a rate of, again that word rate has come up, so it's 0.2 meters per day. So we've got the rate over time, d over dt, and the width x is 0.2 meters per day. So now we can substitute all this in. Now we can say dy over dt equals dy over dx. Okay, so I'll write this out again. Dy over dx times dx over dt. Well, dy over dx, we calculated it. When x equals 15, dy over dx is 3 over 5. And the dx over dt is 0.2. And if we multiply that out, we should get 0.12 meters per day. Okay, it's a bit much to swallow in, but trust me, as you think about it and go through it, it will make sense. You start off, I'll go over this again. So we start off with the chain rule, identify what is needed, so write it out. Let me just put this in a box, okay? And we want to work out dy over dt. So you say, what's dy over dx? So we know what dy over dx is. And you say, well, what's dx over dt? Well, dx over dt is just our 0.2. But they've been specific. They've said the width of the reservoir is 15 meters, and at that point it's increasing at 0.2 meters per day. So therefore, we can get a specific value for dy over dx by substituting this 15 into our dy over dx, and that gives us 3/5. Then all we're doing is going back to our chain rule and multiplying the 0.2 with the 3/5 to give us the 0.12. So all it's doing is using chain rule. That's all you do. Okay, but we'll come on to rates of change in coming lessons, but that's all you're doing. You're applying the chain rule. Okay, and the rate, the word rate always means with respect to time. Okay, I'll leave that on the board for you to copy down. Any questions? Yes?
How did you get x over 25?
X over 25, right, because if you look at this equation, x squared, so this equation here is 1 over 50, x squared take away 2. If you differentiate that, we get 1 over 50 times 2x, take away 0. So that's basically 2x over 50. 2 over 50 can be written as 1 over 25.
Oh,
Is that okay?
yeah.
Thank you. Good question. Any other questions? All right, I'll leave that on the board for you to copy down, and then I'll give out some questions now so you can get started. Okay?